Hey guys, and welcome to part 1 of our 3-part exponent series, right? Today we are going to be going over the 7 basic exponent laws, some basic terminology for exponents. All of this is actually targeted as a review for the Math 10C curriculum, or if you'd like to learn/review the 7 basic exponent laws. Okay, let's start off with our basic terminology, as always. So, currently represented by the variable x is our base. That is the base. Okay. The smaller number that you see, typically, is currently represented by the variable y. Okay. And this whole thing is represented by, not represented by, this whole thing is a power. So what would we say this in word form, or how would we say this in word form? This would be x to the power of y. Okay, just in word form. Now, let's continue up to our first exponent law. When you multiply powers of the same base. Okay, so as long as the base is identical with each power, what you can do to simplify this is add the exponents. And yeah, the exponents can really be anything. It doesn't matter what the exponents are as long as the bases are identical. In this case, it will be x 2 plus 3, which is x to the power of 5. Okay. We have quite the inverse happening in division. So, when you're dividing powers with the same base, what you can do is you can subtract the second power's exponent from the first power's exponent. What do I mean by this? In this case, it would be x to the power of 6 minus 3, which is x cubed. Okay. Another way to simplify. Here is something very important to remember, and a lot of people seem to forget this on tests, and it is quite important. X to the power of 0, or rather anything to the power of 0, x can represent any real number, is always going to be equivalent to 1. So yes, you can assign this a value without knowing what the variable x is representing, as it can represent anything and still be equivalent to 1, as long as it is to the power of 0. Okay? Now, here's a tricky one that apparently a lot of people don't get right. When you have two exponents separated by this bracket, it's a little different than when you're multiplying powers of the same base, since in this case it's actually saying the power x squared is being cubed. So what you do in this case is you'd actually multiply the variables. So in this case, x to the power of 2 times 3, which is x to the power of 6. Okay. Here is the distributive property, which we can actually do in both multiplication and division. I can't stress enough that you cannot do this in addition or subtraction. Do not try to do this in addition or subtraction. It is such a common test error, okay? Do it in multiplication and division. So, what you can do is you can distribute the two. In this case, let's say we have x over y squared, which could also be equivalent to, or which is equivalent to, x squared over y squared. Here we have x times y squared, which is equivalent to x squared times y squared. You don't even need the bases to match up in this case, by the way, which is quite nice. And it does go either way. That's why one of them was written one way and the other one was written a different way. It's not that division has to start off in a certain way. You can start off like this and then just put it into this format. But yeah, here's one that I actually made up while I was making this, as I couldn't find a 7th law. This is super important though. It may seem like common sense. X is always equivalent to x to the power of 1. You just don't write the 1 there. Do not forget that. This is not x to the power of 0. This is x to the power of 1. We just don't write the 1. Very similarly, well, yeah, so something like this is what I'm just astonished with. This is not not equivalent to x cubed. No, there is actually a hidden 1 over here. Now it's 1 plus 3, which is x to the power of 4, right? Don't mess that up, as that is really basic stuff, and for some reason gets messed up. So now let's try a pretty complex problem that I tried to fit in everything we learned in part 1 here. So you may want to pause the video and try it out for yourself, take a go at it. If not, I will explain it, or if you want to see a step done and then do it yourself, feel free to do that as well. Okay, so first thing, I just analyze this whole expression. How are we going to simplify this quite simply? Well, we actually have the same base, which means we should get it down to approximately 2 powers, hopefully 1. We'll see what happens. Yeah, so another thing that you should really notice is that there's the exponent of 4, and that this whole expression here is being raised to the exponent of 4, okay? It's not one of them, it's everything. And you can deal with the 4 right off the start. Some people like to get that out of the way so it doesn't mess them up later on. I'm not going to do that, since I don't like doing that too much, but it doesn't matter. You'll get the same answer in the end. Okay, so let's start with ignoring the 4 temporarily and just looking at the values. So this we could simplify into s times s and square both of them, right? Wow, that does not look like an s, since we can distribute the exponent of 2 onto both of them. And that will be dividing, well, actually, we can assign this a value, right? The value of that is quite clearly going to be 1, but not just any one. This is a negative 1, okay? Don't forget that negative. So we actually have s to the power of 7 multiplying s to the power of 4 minus 1. Okay, and this is all raised to the power of 4, which we're not going to deal with still. Okay, so now up here we actually have some basic multiplication to do, also kind of distributive property. So initially we have s to the power of 7 times s to the power of 4, and that is once again multiplication of powers with the exact same base. So we can add those exponents up to get s to the power of 11. Okay. What about s to the power of 7 times negative 1? Well, that's quite simply negative s7. Okay, or negative s to the power of 7. And as for these, you could simplify that into s to the power of 4. Yeah. And once again, we can't forget the 4 on the outside. Notice how much we've shrunk our expression. It's getting smaller and smaller. Now, up here, we actually can't deal with, firstly, these two are prime numbers, so we wouldn't be able to deal with them even with advanced exponent laws. But yeah, we're just going to leave it like that for now. I would personally get rid of that 4 right now, as we have prime numbers, and when we're going to multiply that by 4, quite clearly they're going to not become prime into nice composite numbers. So, remember that this 4 is multiplying every exponent. So 4 times 11, 4 times 4, 4 times 7. S to the power of 44 minus S to the power of 28 over S to the power of 16. Okay, how, well, what's another way to represent this? We could do it right now, but I'm just going to rewrite it in a slightly different format so it makes a little more sense, and I personally think, yeah, it just looks visually more appealing. So 28 S16. And notice, well, it's not 1 times 6, it's 16. Quite a big difference there. Anyway, notice we have division of powers with the same base, which is subtraction for their exponents. So in this case, we get S28 minus S12. Okay. And that's as far as we're going to go. With this episode, you could actually go further by starting to root this and split it up. But that will be explained in a later episode. I will actually show you how to do this after. But to understand it, I would highly recommend checking out episode 2 and 3 of our exponents. But how would you actually do this, since I personally cannot end off with a problem that's unsolved? What you can do is start factoring this, in that this is a 2, this is a 2, 2, 7, this would be a 2, 2, 3, right? Okay, so we have 2 common. 2 times 2 is 4, so we can take the 4th root of that by going s. What's 28 divided by 4 is 7. S to the power of 7, 4th root there, or to the power of 4 there. And we can go s cubed to the power of 4, which would later cancel those out. Yeah. Okay. Then you'd continue from there. If that looks interesting, I would highly recommend checking out episode 2 and 3. Well, thank you for watching. Good luck on your exams, as always.